Hello and Assalamu alaikum. This video is going to be about something that I faced when I was doing my A levels. At college, uh, or whenever I had to go home. See, there was a very kind of large ground in my college, right? There was this large ground donated by this green. It was a football ground, right? And there was this kind of pavement going alongside it, bordering it, right? So I used to come out from over here, right? I used to come out from over here, and now I had a choice. I could go and exit. The exit was over here. The exit was over here. I could go and exit by traveling along this sort of pavement, or I could start from over here, and what I could do is cut across the ground, right? Now, this shape may seem familiar. It's a right angle triangle. Now, wondered, I wonder which path is more efficient. I mean, there's one way I could find out was that I could end up measuring it, right? But well, no one in their right mind would go about doing that. And then I realized, well, this forms a right angle triangle. So what if I kind of labeled these things, right? I kind of labeled these things as this as A, B, and the hypotenuse, the path that cut across the ground, as C. And well, what I needed to see was whether A plus B, the total distance of the kind of pavement, was greater than C, or A plus B was less than C, or was it equal, right? So I had one equation in mind which kind of related A, B, and C, right? And that equation involves the Pythagorean theorem, and using it, I kind of got my answer, and it was really rewarding to kind of use this technique that I learned in like middle school in the 6th grade and apply it to a real life situation. It was very rewarding. It was a really tiny, and it wasn't really that substantial of a problem, but it felt really rewarding. And for those who think that math is, oh my god, I'm not going to use this kind of math in real life, well, it may come up, and it does show you that this kind of math is used like in day-to-day problems, to solve day-to-day problems. And let's begin solving this, right? Let's try finding our answer. And there's your hint: use the Pythagorean theorem. And I urge you to pause this video and try it for yourself. I mean, it's a really rewarding experience to kind of like solve this kind of real life problem using the techniques you learned at school, right? But if you don't want to, or if you're unable to get to a solid conclusion, then feel free to follow this video. Okay, so let's begin our solution. All right, so the Pythagorean theorem states that a squared plus b squared equals c squared, right? But I want to know if A or B is equal to, greater than, or smaller than C. But I have these squares on top, right? So I need some way to convert these squares into these squares. I have to get rid of these squares. And if I do take a square root, right, like this, A squared plus B squared equals C squared, I can't get rid of these individual roots because there's a plus in between, right? But I can get rid of this. So I'm not going to do that. What I'm going to do is recognize that, there's one identity that involves A plus B squared, right? But that equals A squared plus B squared, plus 2AB plus B squared. So now I have this A squared plus B squared in my first equation, right? But I lack this 2AB. So I can't convert it into this perfect square, right? Into this first algebraic identity. So what I can do is, let me just change a bit. Let me just change color here. A squared plus B squared. I add a to ab, but adding something to one side of an equation means that to keep this equal sign intact, to keep these two sides equivalent, I would have to add the same thing to the other side as well, right? So this kind of becomes a plus b whole square, right, equals c squared plus 2ab. Now I can say that a plus b equals, I can take square root on both sides, and now this is c squared plus 2ab. Now I have this a plus b over here, right? And I've done about half the work, right? But I need to relate this to c. What I have on the right hand side is c squared plus 2ab, right? So that doesn't work for me. But what I can do is realize or notice that c squared plus 2ab is greater than c squared, right? It is greater than c squared because you're adding a positive term to c squared, right? So since c squared plus 2ab is, and if I take an under root, right, c squared plus 2ab, then this under root is greater than c, right? And since this thing is equivalent to a plus b, right, I can replace this with a plus b and say that a plus b is greater than c. And this is true for any case of positive a plus b and c, right? Because you only have positive lengths in triangles. So what we've proven is that no matter what right angle triangle you have, the sum of the shorter sides is always going to be greater than the length of the hypotenuse. So you're always better off traveling along the hypotenuse, right? And that's where kind of, vectors come in as well. You can link this to vectors as well. If you were to draw some axes over here, right, and you have a vector. Now this vector, let's say this was, 6, 2. Now you could travel to get this vector is a position vector of point A. You could travel 6 steps along the x-axis and then 2 steps along the y-axis to get here, right, to point A. But this vector basically gives you a direct shorter path between the origin and A, right? And you, by knowing these components of this vector OA, 6 and 2, you can basically calculate this angle and using the Pythagorean theorem, the length of this vector. So you know that, okay, I have to turn around this many degrees and just walk like this many meters and I'll reach A. That's shorter and that saves time, right? And when you're adding up vectors, this I'll get to you in the next video, right? Instead of walking along each vector step by step, when you add these vectors, you get a resultant vector, which is just the net displacement from the origin to the same point that the two individual vectors take you to. But that involves you traveling a shorter distance, right? So that is kind of one advantage of mathematics, right? It enables you to see the world in a kind of objective manner, right? In a purely analytical form, right? And helps you see helps you realize what the most efficient way to do something is. So this was it for this video. Thank you very much. Please share and subscribe, right? Please leave a comment on how you find these videos. And one tip that I would like to give you is watch these videos at 1.5 times or 1.75 times the speed. It'll go way faster because I talk really slow in these videos, and you'll have a much better time. You'll just kind of get through it a lot quicker. Thank you very much. Allah Hafiz.